We're still talking about static electricity. We're going to be talking about charging by friction. Now, if you paid any attention at all, you should know that charging by friction means you are rubbing two materials together, okay? So you're taking two materials that start off as neutral. When you rub them together, one takes electrons from the other. The one that gets the extra electrons becomes more negative because electrons are negative. The one that gave away its electrons becomes positive. Now, remember, only electrons move. So everyone gets it right when they have to make something negative because they give it electrons. But when something becomes positive, it never gains protons. It's always because it loses electrons. It loses its negatives, so overall it's more positive. So let's look at an example. Okay, I have a ruler and I have a piece of fur or a piece of cloth, okay? So both of them are neutral. So if we count it out, I have this one is +8, and this one has +6, and this one has -8 and -6, okay? So overall, they're both 0, which is a charge of neutral. Now, I'm going to take them and I'm going to rub them together, okay? So I'm going to take my ruler, and I'm not going to use fur. I'm going to use my, my Minnie Mouse cloth, okay? And I'm going to rub the ruler, and when you do it in the lab, you kind of have to squeeze and do it, and you'll hear it crackling when you do it properly. What's going to happen? Turns out the ruler is better at taking electrons than the cloth. The reason is this material pulls electrons more and holds them tighter than this material. Okay, and for that, we're going to talk about that in a second. Let's get back to this. Okay, so when they are rubbing together, the first thing you do, you always draw the positives where they were because positives never move. If you get this wrong, oh boy, you should be in big trouble. This one had 6. 1, 2, 3, 4, 5, 6. So as a little trick, I'm just going to fill them in all the way across because I know that they never move, right? 3, 6, oops, 1 too many, right? 4 and 4. And 6, 5, 6. Positives never move. Now, what happens to the electrons? Well, if the ruler is better at stealing electrons, it's going to keep its 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8, and it's going to take some of the other. Now, this one had 6. I'm going to draw the 6, 3, 4, 5, 6. And what happens during the rubbing? Well, let's just move a number. It doesn't really matter how many, but it must be the electrons that move. And I'm going to move 3, okay? If you move 2 or move 4, it's fine. And when they move, what ends up happening? So this is happening while the rubbing's occurring. At the end of it, I separate, I look at them, and what will I find? Well, the ruler is going to have its 8 electrons from before, and it gained 3 electrons. So it's going to have 11. So it's going to have 11 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. The cloth started off with 6, but it lost 3. So it's going to have only 3. 1, 2, 3. And what happens to the protons? The protons never change. So this one keeps its 8 protons. This one keeps its 6 protons. And what is the charge overall? Well, this one has 3 extra electrons. So it has an overall charge of -3. This one lost 3 electrons, and if you add it up, you end up with a charge of +3. Well, that makes sense. If one of them lost a charge, the other one must have gained it. So the numbers should match, right? So this is charging by friction. The last question you need to know is, how do you know whether the ruler takes the electrons from the fur or whether the fur takes the electrons from the ruler? And it's different for every material, right? So there's no trick you can memorize, but you will receive something called the triboelectric series. You will get some kind of a list. This will be given to you on exams. You don't have to memorize it. So I guess that's kind of nice for you. And in this list, you'll see that you will get some kind of an indication of which materials are better at pulling electrons, better at taking electrons. So here it says increasing tendency of materials to attract electrons. Well, if we go to the top, we have Teflon is really good at stealing electrons. You have silicon, vinyl, polypropylene, and so on all the way down. Usually, as you see, and actually, if you get to the bottom, you usually end up with the clothy stuff, and they usually hold their electrons really weakly. So in kind of a fight for the electrons, Teflon will always steal the electrons. And for example, at the very bottom, dry human skin will always give its electrons. And in the middle, you just compare which one is stronger than the other. So it's kind of like two football players catching a football at the exact same time and trying to wrestle it from each other. The bigger, stronger one, chances are, will win. Therefore, it's similar with this. The stuff at the top of the list will likely win. Make sure you read the label. I can switch it on you and put it upside down and change the direction of the list. You have to read what it says. Okay? So that tells you which one takes electrons and which one gives. That's it for friction.